Okay, so good morning, students. In today's experiment, we have this verification of port characteristics of isolator and circulator. As we know that isolator and circulator, these are microwave components, means they are a part of microwave test bench. You discuss about earlier microwave test bench. So microwave test bench contain diagram like there is a klystron power supply, which is a source of microwave energy, and it is followed by an isolator. So isolator is a device which can be useful for transmitting signal in only one direction. So it in other way we can say that isolator uh, removes the backward signal, means it reduces the backward signal. So we have to go for port characteristics of this isolator and circulator, and whenever you want to finding the characteristics of something, there are certain parameters to be found, and on that parameter you can go for finding characteristics of isolator and circulator. So for an isolator, there are characteristics like you can find out VSWR, that is voltage standing wave ratio, as well as you can find out insertion loss of an isolator and isolation of isolator. So all these three parameters you can calculate it for this isolator. But when we go for circulator, so for circulator you can calculate this VSWR and insertion loss. So isolation is not possible in case of circulator, and for performing this experiment you required a micro test bench, and that micro test bench contained these equipment like it required a klystron mount with a klystron tube, and for energizing that klystron tube, you required a klystron power supply, isolator, variable attenuator, slotted section, then circulator, and as well as we required some either VSWR meter is used, or you can go for CRO for that particular observation of waveforms. So there is certain theoretical part of isolator. So we can say that isolator and circulator both are ferrite devices, and they are using principle of Faraday rotation. So inside, when we go for structure of isolator and circulator, it contain a rotator, so that waveforms get rotated by either 45-degree or 90-degree. So these ferrite devices are used in microwave um, for this isolation and for circulation purpose. So isolator is a two-port device. So when we go for S parameter matrix of isolator, it is a 2 by 2 matrix, and when we go for circulator, it is either a 3-port or 4-port device. So S parameter matrix is like either it is 3 by 3 or 4 by 4. So isolator is useful for transmitting signal in only one direction, means in forward direction. A direction is mounted or it is printed on the isolator, so that that can be used in either forward direction or backward direction. And circulator is again a 3-port device, so which transmits signal in what we can say that circular manner, means in clockwise manner. So when we give input from port number 1, you are getting output from port number 2. When we give input from port number 2, output is obtained from port number 3. And similarly, when you give input from port number 3, you are obtaining from port number 1. So this is about circulator and isolator, that is theoretical description. And there are parameters like insertion loss. So it is the ratio of power supplies by a source of the input port to the power detected by the detector in a coupling arm. Means when we go for insertion loss, it having formula like it is equal to 20 log to the base 10 of V1 upon V2. When we go for formula of this insertion loss, so insertion loss is equal to 20 log to the base 10 V1 upon V2. And here V1 is what we can say that voltage at port number 1 of isolator. Suppose we are going for isolator experiment. So V1 is voltage at port number 1 of isolator when isolator is not inserted, and V2 is output of that particular detector mount or on CRO when isolator is inserted. Means V1 is voltage before insertion of isolator, and V2 is voltage after insertion of isolator. So when you know the value of V1 and V2, you can calculate insertion loss by using formula like it is 20 log to the base 10 of V1 upon V2. and it is measured in decibel because it is a logarithmic scale. And similarly, there is another parameter called as isolation. So for finding isolation, we have to go for V12, means port at input at port number 1 and output at port number 2. So this one indicate port number 1 and 2 indicate port number 2. So input at port number 1, output at port number 2. So you are getting V12, and V21 also means for finding V21 you have to connect isolator in reverse direction. So that is condition like input at port number 2 where output at port number 1. And when you know the value of this V12 and V21, you can easily calculate it isolation by using formula like 20 log to the base 10 V1 upon V21 2 upon V21. Similarly, you can calculate VSWR, that is input VSWR for this particular isolator. So isolator is two-port device, so port number 1 and port number 2 is act as a load here. And for finding VSWR, the formula is Vmax upon V minimum. So you can calculate Vmax and V minimum by rotating wheel on slotted section. You can calculate Vmax and V minimum. And when you know the Vmax and V minimum, you can take the ratio of that Vmax and V minimum for finding VSWR. So this is for these parameters for isolator. Similarly, you can go for circulator. Here we will consider circulator having 3 ports. So you can calculate VSWR for port number 1, port number 2, and port number 3 also by calculating Vmax and V minimum with the help of slotted section. And similarly, you can calculate insertion loss. So insertion loss, you need to find V1 and V2. So V1 is input or output at on CRO before inserting this circulator, and V2 is after inserting the circulator. So insertion loss can be calculated using like 20 log to the base 10 upon V1 and V2, and it is measured in decibel. So all these parameters we have to find out for this particular isolator and circulator. For isolator, you have to calculate VSWR for port number 1 and 2, then insertion loss as well as isolation. And for circulator, you have to calculate VSWR for port 1, 2, and 3. Similarly, insertion loss. So we have to perform this experiment, but actually I had performed this experiment in our laboratory, and I had prepared a video for that experiment, so I will show that video here. Good afternoon, students. Today we have to perform experiment, that is port characteristics of isolator and circulator. So for performing that experiment, we required microwave test bench that is used in earlier experiment to find the mode characteristics of klystron. So same setup can be used here. So that setup contain a klystron tube, the black color klystron tube, and it required a klystron power supply. Output of klystron power supply is connected to klystron tube, and a fan is used as a heat sink for that particular klystron power supply, as well as there is a klystron tube, because that klystron tube contain a filament which get heated as we operate for more time. So a cooling system is required for that. Then it is followed by an isolator, then direct reading frequency meter, slotted section, and detector mount, and output of detector mount is connected to an CRO. This is the general setup of an microwave test bench, and for this today's experiment we have to go for some additional components to be added in this particular setup, like I have to add an isolator as well as circulator. We want to go for finding port characteristics of isolator and circulator, so that isolator and circulator is connected after this particular slotted section, and after that isolator the detector mount is connected, and output of detector mount is observed on CRO by connecting a wire between CRO and detector mount. We have to go for some general settings for performing this experiment. Means there are certain general settings for this klystron power supply, There are two different knobs present on this piston power supply. One is beam voltage, another one is repeller or reflector voltage. So what we have to do is we have to set beam voltage to 250 volt. So I will put this switch on, display select to the beam voltage. It is already on voltage, and I have to increase this voltage until it reaches to 250. Whenever it is reaches to 250 or nearly equal to 250, then I have to go for checking beam current, and for that purpose I have to move this knob from voltage to current, and this is value of beam current in milliampere, which should not be greater than 25 milliampere. As we progress in this experiment, it may be possible that the beam current get increases, and whenever it more than 25 milliampere, then you have to switch off the Klystron power supply, cool it or wait for some time, and then perform the experiment again. Then beam current is 90 milliampere, it is okay. Then I have to go for this repeller voltage, and there is a knob like reflector voltage. It should be present over beside this beam voltage knob, and I have to move this beam voltage knob in anti-clockwise direction until I have a waveform or the first mode on CRO. So I will show you a CRO. Everyone's here. This is output on CRO, and I am now moving the repeller voltage until I have some waveform on CRO. So I am moving this in anti-clockwise direction, and I will take this as observation. So at 191 volt of reflector voltage or repeller voltage, I am getting the first mode of reflex piston, and that should be sufficient to this particular experiment. And after this setting the knob of this particular repeller voltage, the next thing is that I have to observe the waveform. Means I have to take the reading of that waveform, how much the waveform it's having voltage. So for observing that, I have to go for adjusting this Y position to middle, and then I will take the reading. So it should be nearly equal to 2 multiplied by channel 1 is having value 0.5 volt. So it is 2 multiplied by 0.5 volt. This is the value of, say, it should be V1, 2 multiplied by 0.5 volt. So this is what we can say, that value of V1 which we are getting from this particular experiment. And everyone listen here, I had not connected. Okay, so now in second part of this experiment, an isolator is connected after the slotted section, and output of isolator is connected to a detector mount, and then output from detector mount is connected to a CRO. So isolator is inserted in between a slotted section and detector mount. All other setups is same as compared to the previous one. So we had value of V1, so that is equal to 2 multiplied by 0.5, which is equal to 1 volt. And here we want to find out value of V2. So when you observe the value of V2, it is nearly equal to 1.2 multiplied by 0.5, so that is equal to 0.6 volt. So you are getting V2 equal to 0.6. So you are getting V1 and V2 now, and that should be the value of V1 is voltage up before insertion of this isolator, and V2 is voltage after insertion of isolator. So you are getting this V1 and V2, and by using this value of V1 and V2, you can calculate the insertion loss, so which is equal to 20 log to the base 10 of V1 upon V2. By using that formula, you can calculate V1 and V2. Similarly, isolator is a two-port device, so port 1 is connected to a slotted section and port 2 is connected to a detector mount here,
and a direction is present over that isolator. Now we can find out the VSWR of this particular isolator whenever port 1 is connected like this and port 2 is connected. So for finding VSWR, we have to move the VLAN slotted section until you are getting the Vmax value and Vminimum value. So I am moving this VLAN slotted section to the left side, and as I am moving this V1 is great, voltage is increasing, but after some time it start decreasing, so I have to go for that point where it is maximum 1, and here you are taking this value, so which is nearly equal to 2 multiplied by 0.5 volt, so that is equal to 1 volt, which is Vmax. And for finding Vminimum, you have to again move this, so until you are reaching to the minimum point. So after this point it start increasing, so we have to go for this particular point, and whose value is equal to, say it should be 0.5 multiplied by 5, so it is 0.25. That is the value you are getting from an Vmax and Vminimum. And when you know the Vmax and Vminimum, you can find out the VSWR easily. And there is one more thing that can be, or one more parameter we found using an isolator or for an isolator. So that is isolation. So for finding isolation, you have to go for first finding V12, and then you have to find out V21. For finding V12, you have to go for keeping isolator in this position like this, means port 1 is connected to slotted section and port 2 is connected to detector mount. Then you can find out V12, and its value is nothing but, or it is equal to V2, so it is 1.8 multiplied by 0.5 volt, so it should be equal to 0.9 volt. So this is value of V12 you are getting. And for finding V21, you have to connect this isolator in reverse order. Reverse order means this particular arrow you have connected to slotted section, and this you have to reverse this order of isolator so that you can find out the V21. And same experiment you can perform on circulator also. Here this is the circulator, circular information or circular mark is present over here that indicate the ports. So a circulator having 3 ports, like it is starting from this position, so this is port number 1, and then this is port number 2, and then this is port number 3. So a circulator having 3 port device, and you can connect port number 1, then output you are getting from port number 2. You can connect port number 2, then output you are getting from port number 3. And when you connect port number 3, then output you are getting from port number 1. So similar procedure for isolator you can apply for circulator also, means you can find out the insertion loss of circulator. For finding insertion loss, you have to find out the V1 and V2. So V1 is before voltage before insertion of circulator, and V2 is after insertion of circulator. Then you can find out VSWR for 3 ports of circulator, means you can calculate, you can connect port number 1 to the slotted section and output is taken from port number 2, whereas this port number 3 is terminated using match termination. So in this way you can find out the VSWR of port 1. For port number 2, you have to connect port number 2 a slotted section, output from port number 3, and in this case port number 1 is match terminated. And then suppose if you want to find out VSWR for port number 3, then port number 3 is connected to a particular slotted section, output from port number 1, and port number 2 get terminated using match termination. So for this isolator and circulator, you are performing parameters like there is for isolator there is insertion loss VSWR as well as there is isolation, and for circulator there is insertion loss and VSWR only. Isolation is not present in case of circulator. So for finding isolation, what we have to do, we have to connect this isolator in reverse order. So your isolation is equal to that 20 log to the base 10 of V1 upon V2 or V12 upon V21. So you are getting V12, so that is nothing but it is equal to point 0.8 multiplied by 0.5, so it is equal to 0.9 volt. For finding V21, you have to connect this particular isolator in reverse order. So for finding isolation, we have to find out V21, and V21, for finding V21 we have to connect this isolator in reverse order like this. Means here port number 2 is connected to slotted section and port number 1 is connected to detector mount, and output of detector mount is present on this CRO. Ideally, no waveform should be shown on this CRO because isolator is useful for transmitting signal in only one direction, but there are physically or practically there are certain values it should be present. So it should be equal to 0.2 multiplied by this is 5 millivolt. So this output is in millivolt. It is very less as compared to the provided input. So you are getting this output, and by using this V21 you can find out the isolation. So isolation is equal to 20 log to the base 10 of V12 upon V21. So V12 means in port 1 is connected to slotted section and port number 2 is connected to detector mount, whereas V21 is in reverse order, means port number 2 is connected to this slotted section and port number 1 is connected to detector mount. So in this way you can calculate insertion loss, isolation and VSWR for this particular experiment, that is isolator. And same procedure you can apply for circulator here, and only for circulator you have to go for finding VSWR for port number 1, 2 and 3, and insertion loss means for finding insertion loss you have to need V1 and V2. So V1 is before insertion of circulator and V2 is after insertion of circulator. So in this way you can perform port characteristics of isolator and circulator.
Okay, so I hope all of you are getting how to perform this experiment. Uh, by using this experiment, we can found parameters for an isolator, like there is input VSWR for port number 1 and 2, and then there is the insertion loss for finding V1 and V2 for isolator, as well as isolation by finding V12 and V21. For finding V21, we have to connect isolator in reverse direction, and ideally a value of V21 equal to 0, but in practice there is certain leakage of waveform may be possible from an isolator due to physical conditions. So millivolt output you are getting for a V21. So isolation is again measured in decibel. And for circulator, you can repeat the procedure for isolator. You can calculate the VSWR for port 1, 2, and 3. Similarly, you can calculate insertion loss for this V1 and V2. So this is for this particular experiment, isolator and circulator.